All right, guys, so this is a quick overview of how to remember the intrinsic and extrinsic coagulation cascades. So remember 12. Sorry, let's do this. Better. Okay, so we have intrinsic. I'm going to put this in green color, okay, just to make it easy for you. So you have 12, 11, 10 is what you're trying to get at. So remember that all of those coagulation factors, they combine right here, and 10 is is what all of them converge to. Okay, they all converge to. All paths lead to 10. All paths lead to 10. Just remember that as a little phrase. All paths lead to 10. Okay, so you have 12, 11, 10, of course, that can be skipped, 9, and then, of course, 8 is a cofactor, so I'm going to write it right here, 8. Okay. And then you have 7, pretty easy, right? 7 is pretty much going there. And then from 10, you have 2, and then obviously factor 1. 2 is thrombin, and then 1 is fibrin or fibrinogen. Okay. And then the thing to remember is, of course, these guys right here are the intrinsic. And it has a lot of factors, so it's going to have PTT. Remember, PTT is long word and a lot of factors, so that's PTT. And intrinsic, let's put it in blue, intrinsic is going to be PT. An intrinsic pathway is activated by tissue factor, and it's also the tissue factor that's released by the endothelial cells. So to do that, I'm going to just draw some endothelial cells right here. Endothelial cells right here. They are releasing tissue factor, and the tissue factor goes and activates factor 7A. Now also remember that 8A and 9A, 8A carries, it stabilizes von Willebrand factor. Put this in different color. It stabilizes von Willebrand factor, so this is important. Also, this is hemophilia A. So I'm going to put this in red. Deficiency of factor A is going to be hemophilia A. This is hemophilia B. And obviously also remember that anytime factor 8 is also a common factor for inhibitors. Okay. Also, anytime you have a problem with factor 9 and 8, obviously you're gonna mess up the intrinsic pathway, but the extrinsic pathway is working fine. So that's why your bleeding time is going to be normal, and also your PT is going to be normal. Your PTT is going to be high. Also remember that the platelet counts are normal because we're talking about coagulation factors. This is the secondary hemostasis. So here you have the things with the anytime you have a factor 8 deficiency, you might also have problems with von Willebrand factor, von Willebrand disease, because von Willebrand disease stabilizes factor 8. So anytime you have a problem with von Willebrand disease or von Willebrand factor, it's going to mess up your factor 8 as well, and it's going to increase your PTT. So just be mindful of that. So I'm going to put this right here. This is a very high yield fact to know. And then let's talk about, so this doesn't work. I mean, this should give you a good idea of how you should remember the extrinsic and intrinsic pathway, and of course a common pathway. Also remember that thrombin can activate a whole bunch of other guys. So thrombin can activate, I'm going to put this in different color again. Thrombin, which is factor 2, can activate, this is factor 5, so I'm going to put this right here. Factor 5, which is part of the common pathway. I forgot to put it right here. So this is factor 5, right? So thrombin can activate factor 5. It can also activate thrombin's TSF. I think it's thrombin stabilizing factor. And basically what that does is it just increases factor 13 and TSF. So just you can think of it, factor 13, thrombin stabilizing factor. Thrombin can also activate plasminogen. And remember, plasminogen is a cutter. So it basically, so I've driven it as like this cutter, like a crocodile. Sorry, this is a thrombin also activates plasmin. And plasmin, remember, is a it degrades fibrin. Excuse me. This is a plasmin, and remember, plasmin comes from plasminogen, and it's basically a cutter, so it degrades fibrin products. Fibrin. So it's kind of, think of it as a safety mechanism, right? Like you are making a clot, but you also activate plasmin to make sure that you don't overclot things. And it leads to D-dimers. D-dimers, remember, are just a breakdown, a natural breakdown of fibrin. Now, the other thing to remember is that another check that your body has is protein C. Protein C has a cofactor, which is cofactor S, and these guys, their job is to inhibit, and I'm sorry for all this red here, their job is to inhibit factor, or cut down factor 8 and factor 10. Okay, so what color should we make it? Okay, so this is protein C, and its job is to block factor 8 and factor 10. So this should give you a brief overview of how the coagulation cascade works and how you should remember. Remember that vitamin K dependent factors are all the vitamin K dependent factors are factors 2. So let's put vitamin K maybe with a different color. So these, oh no, we have too much of this, yeah? Let's maybe make it gray. Okay, so these guys are vitamin K dependent. Vitamin K dependent. So vitamin K dependent factors are factor 2, factor 2, factor 10. They're also factor 9 and factor 8. So these two guys, and obviously protein S and protein C. So vitamin K dependent, these are really dependent on vitamin K. So hopefully this gives you, I know it's a little bit messy, but it should give you a brief overview of how to go about remembering this cascade.